Alright guys, hard to believe, but we are in the last chapter um, before your final exam, chapter 6. In chapter 6 we'll be all learning about different types of systems of equations and things like that. So we're going to focus in on this first section in 3 different ways to solve systems. The first way being graphically, by graphing. The second way will be by the substitution method. And the third way will be by elimination. When I was in school, we called it linear combination, so you may have heard it referred to that way. So these are going to be the 3 methods we're going to focus in on. This first section, your homework is page 483 to 488, 5 through 75, multiples of 5, and multiples of 5. What I'm going to do is I have 2 days set for us to cover this. So in the first day, which will be tomorrow, the 20th, I know a lot of you are going to miss for different things. We got undergraduate luncheon going on in the middle of the day. So I'm going to try to go over, expect you to know at least through problem 40, and then we'll go over the applications, which start with problem 45. We'll go over those on Tuesday, and hopefully a few more of you will be able to be there for that. All right, so the first set of problems we're going to solve graphically. So to solve graphically, I'm going to want to have a graph, and you'll have a couple of equations. So let's say I'm going to try problem number 12. 2x minus y is equal to 1, and 3y equals 6x minus 3. So the very first thing you want to do is solve for y in both equations, and then we're going to graph them, and we'll look for the point of intersection is what we're looking for. So for this one, if I subtracted 2x, I get negative y equals negative 2x plus 1. Then I divide everything by negative 1, I get y equals 2x minus 1. Because when you divide this by negative 1, it cancels a negative, makes this one negative. So to graph that, I would come up here, pick a line, and I would start at negative 1, and I would go up 2 and over 1. This is not going to be the best way to draw the line. Start at negative 1, that's going to be my y-intercept. My slope is 2, so I'd go up 2 and over 1, and I'd try my best to draw a line that goes through those points. And let's see, maybe I can get a line. Nope, not working. Okay, this line that goes through here. So just imagine that there's a line. If I try to draw it, it's going to be all kinds of crooked, but I'm going to try. Okay. The other line, if I divide by 3, look what's going to happen. Y equals 2x minus 1. It's the exact same line. And that sometimes happens with systems. Once you solve them for y, you see that they're the exact same line. And when they're the exact same line, my answer is that there will be infinite solutions, because every point on this line is a solution to both equations. Like the point 0, negative 1 is an answer on this line. If I plugged in 0, negative 1 for x and y, it'd make a true statement for both equations. The point 1, 1 is a solution on this line. If I plugged in 1 for x and 1 for y, it'd be a true statement in both equations. So whenever you have 2 equations that graph as one line, your answer is infinite solutions. While we're here, let's go ahead and talk about the other 2 cases. What if you end up with parallel lines that would never touch? When that happens, your answer is no solution. And then the third case is when there is a solution, you're going to have lines that cross somewhere, and that point of intersection is your answer to the equation. So you can have infinite solutions if it's a single line, no solutions when they're parallel lines, and you'll know they're parallel because the slopes will be the same. So that'll confirm that they're parallel, or the 2 lines could intersect. Let's find one. Let me show you an example of ones that intersect right quick. All right, problem number 9 is x plus 2y equals 1, and then it's x plus 4y equals 3. X plus 2y equals 1, if I solved it, I get 2y equals negative x plus 1, divide everything by 2, I get y equals negative 1/2 x plus 1/2. So to graph that, I'd start at a half, which is here. I'd want to go down 1 and over 2. Down 1 and over 2, and hopefully this is a lot neater on your paper than it is on this smartboard slate. It's hard to do. Okay, so that's what the line is going to look like. and I'm not going to connect it because it would probably make a mess. Alright, for this one, I'm going to subtract x, divide by 4. I get y equals negative 1/4 x plus 3/4. So here I'm going to start at 3/4, which would be around a little bit above 1/2. Should probably change the color, be easier to see. Start at 3/4, go down 1 and over 4. Go down 1 and over 4. Go up 1 and over 4. So a little bit above that, 3/4. If I do this, I think right here is where they're crossing, which is negative 2 1/2. You may need to, if it's hard to tell on your paper, like it is hard for me to tell, especially with this that I have going on here, you may want to put it in your calculator and find the intersection point. Hang on, I'll pull the calculator up and we'll look at that. Alright, to make it a little faster, I went ahead and entered these in the calculator, so you can see negative 1/2 x plus 1/2 and negative 1/4 x plus 3/4. If I were to graph them, you can see a little bit clearer where they're intersecting. It looks like I may have been correct or somewhere. It actually looks like it may be at negative 1 something. So second trace, we're going to find the intersection point, and we just want to make sure it's blinking on the first curve. So I push enter, second curve, now it's blinking on the second curve. Guess, I'll push enter one more time, and it is the intersection point at negative 1 1. So my answer for this problem would be negative 1 1. Whoops, negative 1 1. Alright, second way that we can solve systems is by what's called the substitution method. And with the substitution method, what you're going to want to do is you've got two equations, and you want to take one and solve it for either x plus x or y. I'm going to take a look at number 17, and then you're going to take that result and plug it in place of that variable in the other equation. So for instance, if I solve for y, I'd get y equals 9 minus x. I'm going to take this and put it over here where y was. So instead of 2x minus y, it becomes 2x minus 3 times 9 minus x, because y is 9 minus x. And so then I would get 2x, and then minus 3 times 9 would be minus 27. Minus 3 times a minus x would be plus 3x. This is where your algebra, you don't want to get messed up with your symbols or your signs. And then combine like terms, 5x minus 27 equals 2. Add 27, you get 5x equals 29. Divide by 5, you get x equals 29 divided by 5 is 5.8. So my answer for this problem would be 5.8 for x. If x is 5.8, go back to your problem over here. If x is 5.8, what's y going to be? 5.8 plus what is 9. So y would have to be 3.2. Now, you want to make sure it works. So over here on my calculator, I'm going to make sure that if x is 5.8 and y is 3.2, that it adds up to 9. 5.8 plus 3.2 does equal 9. And now let's check it with the other equation, which is 2x minus 3y. I need to get negative 2. So 2 times 5.8 minus 3 times 3.2. And then I get 2. I was supposed to get negative 2, wasn't I? I totally left off negative 2 in this problem. Let me go back and fix that. That's the problem. So, go back over here, and this should have been a negative 2 all the way down. So if I add 27, I get, add 27 and negative 2, I get 25, and then divide by 5, x is 5. That works a little bit easier. If x is 5, then y is 4. Now check our answer. 5 plus 4 is 9. That works out. 2 times 5 is 10. Minus 3 times 4 would be 12. 10 minus 12 is negative 2. That works out better. Definitely why you need to check your answer. 5, 4 is the answer. Alright, the last way to solve, and probably the way that I prefer, is what is called the elimination method. So with the elimination method, let me pick one that's a little bit tougher. Problem 36 is x plus 3y equals 0, and none of these are really tough. I just wanted one where we had to actually find a way that when you line them up, sometimes when you line these up, either the x's or the y's cancel out already, and so you don't have to do any multiplying by any factor to make them to where they're the same. But here, our x's don't cancel out and our y's don't cancel out as it's written. So what we want to do is find a way to cancel. So for the x's, if I wanted to cancel the x's, I could multiply this top line by -20, and then they would cancel. For the y's, if I wanted them to cancel, I can multiply the top line by 5, because that would make this 15 and this is -15. So I think I'm just going to do by 5. It's a little bit easier number to work with. So if I multiply the top line by 5, it becomes 5x plus 15y is equal to 0. And the bottom line stays the same. And then what I do is I just combine these two lines. 5x and 20x is 25x. This cancels. 0 plus 75 is 75. Divide by 25, you get x is 3. There's one of my answers. I'm going to go back to my original problem before I multiplied it by 5. And if x is 3, then I get 3 plus 3y equals 0. Subtract 3, I get 3y equals -3. So y would have to be -1. So my answer is 3, -1. Let's make sure it works in both equations. 3 plus 3 times -1 is 0. That works. 20 times 3, that'd be 60, minus 15 times -1, so that'd be plus 15. 60 plus 15 equals 75. It checks out for both, so that is how you do the elimination method. So if you can try to at least get through problem 40 today, we'll look at the applications of this tomorrow, and you should be in good shape.